I actually worked with Dave on that project. And that was my first BIM experience, and I can't get enough of it. So with the advent of BIM, I'm asking, what's it mean to build an information model? And we're realizing that a model is actually very malleable, and that it's the objects in the model that make it malleable. So we created an object management system to help us take advantage of that fact, or opportunity, depending on which way you want to take a look at it. So what we found was that good BIM models function as they do because they rely on the consistent use of intelligent objects. So in order to have a good BIM model, we need to understand how the BIM library works. And that's a little different than how an AutoCAD library works. We have to understand now what are the parts of the BIM library, how do they work together, and what's the best way to use them. Basically, what we found, the BIM library has three parts: smart objects with minimal intelligence, parametric objects, which have a lot of intelligence, and marker objects, which are just simple text blocks, but nonetheless objects themselves. Our object management system works with the smart and parametric objects to bring about a better model. So as you can see here, anything can be a smart object, including rooms and building fields. They can be high resolution or simple boxes. And there's real need to use these carefully. But what happens when we don't use them carefully? Well, objectionable objects wind up in the model, like these colorful chairs. It's actually happened to us. So what are we to do? Well, it's clear that smart objects need management, just like well-intentioned designers do. Robust workflows and simple standards form the cornerstone of that system. And we rely on parametric objects for that cornerstone, as they can be programmed to manage the smart objects for us. So parametric objects respond to their surroundings and act on user input. These are like self-contained computer programs running within the BIM model. Doors and windows are usually a pretty good example of parametric objects. As part of the object management system, we made our own parametric object called the scale-sensitive cube. The scale-sensitive cube acts as gatekeeper. So one simply types in an object's ID number and the object pops up on the screen. And it doesn't matter what the object is. It can be any object, but the system always presents the user with the exact same interface. So it's easy to use. And from this screen, users can also get more information from the object. A lot of times what we'll do is we'll link things like cut sheets or anchorage details directly to the object. So that really helps people understanding what's involved after the work is done. And even things like photographs, previous installs. This is really important for the younger folks in the office to understand. What we can also do is globally change objects. For example, with this item, we can put it in the model as is, but later on, working with our structural engineers, we can include the anchorage into the object, so that when the object moves, the anchorage moves with it. So this helps us a lot with conflict catching and all manner of things. The other thing we can do is even put in real product geometry. So there's a lot of subsystems running in the background that help us do that. And that's what you're seeing here. We've got basically an object control matrix, which controls items going into the model, and a results engine, which analyzes that information after it comes out of the model. And that's where the garbage in and garbage out analysis becomes real. This methodology that we have is fundamental to how a whole system works. It's an approach that really affords us a different view on the topic of model maintenance, which I really think is actually model optimization. It responds to the reality that in the BIM world, the architect's deliverable is now becoming very malleable. So how much we use the object management system is how malleable our model can be. So that means if we want our model to react in a predictable and controlled way, then we need to use the object management system as much as possible. This is the second part of the system, called the object control matrix. So this is basically a list of everything we need to know about our objects, and this is where the scale-sensitive cube goes to return data into the model. It's a simple lookup function, basically. And the system allows the scale-sensitive cube to present objects in any kind of format, 2D, 3D, high resolution, and resolution. It's really all controlled from this central system. So it's nice to have one clear guide for everything. And basically, what it's allowed us to do is to create sort of a library of vetted objects. And because it's a spreadsheet-based system, we can sort of infuse it with intelligence. For example, if somebody puts the object on the wrong layer, that object will highlight in red. It's very useful for us. And because it's a spreadsheet, we can look at that information in 100 different ways, like use pie charts. We have all manner of ways of looking at information. And that's really the third part of the system, the results engine. So this is when the data comes out of the model. So we export the data out of the model, and we put it into Excel, and we can have things like pivot tables, which are over there, or pie charts, which are on the right. So it's important to give people various options at looking at all this data. All these views are built using the exact same protected and remote data source. They can be filtered and sorted using any object control matrix, 30 data points. That's a lot of capability that we give our people. Using Excel's pivot table function, we can sort the data using a simple drag and drop interface. So this makes all kinds of data analysis easy, simple, and actually even fun. I have to admit that this is actually an export of all 65,000 lines of data coming out of the model. So when you have that much, you have to keep it fun and useful. If you don't, it will just ignore it. Here's an example of the pie charts, which shows which objects are official and which are not. Your darker objects are official, your lighter objects are not. So this sort of gives staff a bird's eye view of where they need to do more work. And behind the pie charts are room by room lists, which pinpoint the location of every single object in the model. So we can tell everybody exactly which rooms and which items they need to work on. So in conclusion, it's important that architects realize that they're establishing new ways of understanding design intent by using all that BIM has to offer. And we are quickly becoming